to the Session 4 Engineering Webinar, Smart Seasonal Reset Strategies for HVAC and BAS Systems. We've got a couple of wonderful people that decided to join us to hear a couple of speakers. We have Tom Arnold, co-founder and CEO of Gridium. He also serves as chair of Energy, Sustainability, and Resiliency Committee at Building Owners and Managers Association of San Francisco. Prior to Gridium, Tom was vice president of energy efficiency at Internoc and co-founder at TerraPass. Tom has an EBA from Wharton School of Business and at the University of Pennsylvania with a BA in economics from Dartmouth College. And thank you, Tom, for offering to give their speech today. I appreciate that, a little webinar. We also have joining us Mark Jones. Mark Jones works for Metro Services. He's currently at Shorenstein 601 City Center building downtown Oakland. Mark has 40 years of experience in engineering as a stationary engineer, 30 years as a chief. I actually started with Mark in 1986 at the Wells Fargo Data Center on 5th Street in San Francisco, not to age us a bit there, but worked with Mark most of his career. He's been an influential force in millions of square feet of construction projects, including major modernization of existing commercial buildings, high-rise buildings from the ground up, and as well as tenant improvement and construction have followed. Mark has a Bachelor of Science degree in Marine Engineering from California Maritime Academy. Guys, thank you both for working together on this four-session webinar that we have for engineering. I know you guys work together pretty good. We had a couple of meetings before, and we're really excited to see this presentation. So without further ado, Tom, take it away.
Rick, thank you for the kind introduction and for dating at least one of the speakers. I'm excited for the conversation today. What I'm going to try and do is introduce a handful of concepts and data, have a conversation with Mark that taps on his experience in his current situation, and also open the floor for some discussion. I think it's a small enough group that we can have Q&A. If you've got something that you want us to talk about, throw it in the chat, and then we'll certainly open it up and open the lines up at the end for discussion. And thank you to BOMA Oakland East Bay for the opportunity. I wanted to start with something that I posted on LinkedIn, which I think was actually the genesis of this, which is I sort of made this throwaway post that every chief engineer in America should get a subscription to the Wall Street Journal based just completely on this graph. And this was an article that was written in late September. By the way, that post has almost 100,000 views. It suddenly hit a nerve. But I suspect this data tracks with what everybody is feeling. And that is that 5 years on, the notion that 100% of your building occupants are going to be 8 a.m. to 5 p.m. 5 days a week is just not in the cards. It's a very different world. And even in New York, which is probably the most stringent RTO market, we see that Fridays are very difficult to get attendance, even in financial services. This is kind of the gap here. By the way, the red line is, or sorry, the darker line here is announcements, and in terms of requirements, up 12% in just a year, and the actual attendance is flat as a pancake. Mark, do you want to comment on your situation with actual physical occupancy and perhaps what you're also hearing from other chiefs and other buildings around you?
Yes, Tom. Yeah, here in the property that I'm at, on a really busy day, we might get 300 people in 380,000 square feet that's built out. Our anchor tenant is Blue Shield. They seem to be the worst offender, where they keep require people come in the office more and more and more and more. But yeah, we're not really seeing the any increase in occupancy to what the systems were built and designed for.
So well over 1,000 foot per square person
Yeah.
on the most intense days, and I'm guessing on Friday it's way lower.
Yeah, I don't have an actual count necessarily, but Tuesdays is our biggest day. That's when our anchor tenant requires a lot of folks to come in to attend meetings and such. But both Mondays and Fridays typically tend to be a very low occupancy.
Yeah, yeah. And just in terms of your neighbors, you feeling like the same thing is happening in your particular area of Oakland?
Yeah, I think it's going on everywhere in the whole country, basically, but certainly in other areas in downtown Oakland.
Yeah, yeah. That's what matches our experience as well. Um, what does this look like from a data perspective? So these are two little snapshots. And by the way, both of these buildings, I won't disclose the buildings, but they're both in the same submarket and would be aligned with those same occupancy trends. Let me just explain this graph for you if you haven't seen this before. These are the time coefficients on Gradient Analytics for two Gradient customers. And so basically what it's doing is stripping out the weather and giving you the average load at different times for the building. I just picked 2 p.m. So you can see the spread of days here. But for the building on the left here, we can see that if Wednesday and Tuesday are the highest days, average demand is about 319 kilowatts. Friday, with presumably much different occupancy patterns, we saved a whopping 6 kilowatts, not even enough to sneeze at. Um, Building on the right here, Tuesday is their top day at 296, and over 33 kilowatts are saved on average for the same timestamp on Friday. So, over 10% total energy savings because of the way that the building responds to occupants. This is kind of like the big spread that we see in assets today. We see some assets that just simply run the same thing every day, 5 days a week, irrespective of who's in there and what day type it is. And then we see an emerging advanced class of buildings that where it's very obvious that both the engineering leadership and perhaps the automated sequences are doing a better job of matching energy services to the true call for energy demand. Mark, you want to talk about your thoughts here? You have and maybe talk a little bit about your building. You do have a luxury of beautiful new construction, full DDC, and also sequences that are designed to respond to those zone level requests.
Yeah, I'm one of the fortunate few that I have a lot of tools and strategies available to me as far as operating the BMS HVAC controls. Not all the same folks have all of the same types of tools, but HVAC falls under the laws of physics, same as it does for pneumatic control, same as it does for DDC control. Some things that we do, we have a couple different flavors of, I guess, non-occupancy. We have tenants that have pulled back and are not occupying space that is actually leased. And we have other space that was built as a speculative suites, and those spaces are also unoccupied or slash vacant, um, but they're not leased. Um, One thing to be considered about if a tenant has pulled back in some space. There's very likely lease requirements that you have to provide, even though there's nobody sitting there. Um, some things that I have done is basically met with the property management as well as the facilities team for one of our tenants, and discussed things like widening my deadband. Typically, thermal comfort is 70 to 74. Widen it from 68 to 76. And then rather than provide HVAC over the course of an entire business day, start it later in the morning and end it early in the afternoon. Um, you need to balance leasing requirements with what you'd like to achieve. That's kind of my caution on that. For the unoccupied vacant spaces, such as speculative suites, a good consideration is, since there's basically no human bodies in there, to really cut back on the amount of minimum fresh air that you're sending to the suite. Once again, consider widening your deadband as well as your hours of occupancy. Um, the downside to that is, leasing agents are notorious just for showing up. And it would certainly be bad form that you're trying to attract a lease tenant and they come in and either the space doesn't smell fresh, or it's too hot, or it's too cold. You can be effective with these strategies, but it's bigger than you, and it's getting on board with the property manager as well as getting on board with the tenant facilities team.
I think that's really good background, Mark. Let's build on that and return to the so-called laws of physics and take everyone back to uh, engineering class and remember our friend the fan laws. Um, just as a reminder, I the several relationships are at play here, and Mark talked about you know setbacks and dead bands, but for many of you, the actual fan speed and the fan energy related to ventilation is the primary difference between what is viewed as wasted energy versus satisfying a fully occupied humming space. And just as a reminder of these relationships, when you think about the relationship between CFM and speed, it's linear. Higher fan speed, higher CFM. When you think about the relationship between speed and pressure, it follows a square function. And you can see the change here. When you extrapolate that to power, and power is what we care about because that's what hits the electricity bill, it's cubic. And everyone, I think, has been exposed to these laws, but just to hammer it home, I put them all on one graph for you, so that you can see these relationships as they relate to fan speed. And a good mental rule here is to follow the curves and recognize that if we take the fan speed down from 100% from its design conditions down to just 80% or a 20% um, fan speed reduction, we lose one half of the power. That is taking a very small changes to these fan speeds in a variable fan system yields extremely large energy savings. And that's an opportunity for everybody, because if we're thinking about a diversity of space needs and an occupancy pattern that might not be static, if we aim at areas where there's little less occupancy, little less ventilation required, maybe perhaps mild days, there is a good fountain of savings underneath that in terms of the fan laws. Um, I Let's talk about these design conditions. And um, Mark, I think I'm pretty familiar with this view. Probably everyone has a graphics that looks like this. A set of VAVs on a floor and a flow minimum. And when I often ask the uncomfortable question of our chief engineer customers, "Hey, where'd those minimums come from?" Um, the answer is, I don't know. I've been here 10 years and they were here when I came here. There is this layer cake effect of TI after TI after TI, not necessarily the greatest documentation practices, and minimums that might not reflect the current state, in particular, the current state of occupancy, or what's changed in the building since then. Are those VAV minimums that assume fluorescent and halogen lights? Do they assume CRTs? Our space just gets more and more efficient, and sometimes the airflow doesn't really catch up. Mark, you've run over your storied career, you've run all kinds of things, and in inherited buildings, you have the luxury of starting something new, basically from design conditions. But for those attendees that have inherited something that's been built out over years and years and years, when you see flow minimums like this, what are some of your thoughts?
Uh, it's really so when you come on to that existing property that's been up for 10, 20, 30, 40, 50 years, it's really invaluable to be able to find the original design and understand, what your systems are really capable of providing because we work in a finite situation as far as the amount of cooling that's available, amount of heating, and amount of airflow. And hopefully you've got access to the core and shell drawings. They can be very helpful. Hopefully you have access, maybe if it's a relatively newer property, to the basis of design, which will kind of tell you what the systems were, what was in the designer's head when they specified certain systems as such. Um, I think, Tom, kind of an important aspect of all this is as operators, we kind of assume that whoever did the design and whoever did the BMS setup, uh, really understands what's going on and are basically, in essence, as a higher level than us. I found in many of my case, in many cases, the designers aren't necessarily smarter than us, and they'll put in values kind of to cover their butts so that they won't get sued. Fortunately, California has Title 24, which does put some caps on, how big a systems they can design and such. So as operators, it's really important for us to embrace that the BMS is ours. We're the operators. It's really here for us. It's not here for the designers. It's not here for the contractors. And if you are somewhat intimidated by it, just kind of sit back and think of the basics and what you're trying to achieve, which is provide constant tenant comfort in an energy efficient means, and really take away the stigma of that you're not smart enough or you're not familiar enough to operate your BMS. We have issue. I have started up many buildings, many TIs. Typically, that first go around, first couple few months, it's just I'm too cold, I'm too cold, I'm too cold, I'm too cold, and basically, it comes back to the minimums. the occupied minimum amount of air that the designers have put into the system.
Yeah, I mean that's why I'm focused on the minimum here, and Bill makes a good comment in the chat about air exchange rates. That's one way to examine it. The other is to use the existing state of the art standard, which is ASHRAE 62 1. And if you pull up the tables for that standard, it's just three very simple parameters. So first is the occupant density. If you have actual numbers, you can use actual numbers. But ASHRAE suggests using 1 per 200. I think that's about right for our area. If it's a God forbid WeWork space, maybe it's more like 150. Um, uh, or if it's New York and a boiler room, maybe more like 150. But about that kind of number. There's an outdoor air rate, that is RP in the standard. That's simply 5 CFM per person. And then there's an outdoor air rate, which is 0.06 CFM per square foot. And when you take the minimums from a graph like this and line it up against the standard, and we've done this dozens and dozens and dozens and dozens of times, you will find that you are shocked at the level of overventilation on the minimum side. And what that means is that even though the zone is reaching set point, that is the zone is satisfied. The box should be closing up. Those VAV minimums are enforcing a level of minimum airflow that keeps my wife in hats and scarves and gloves at Stanford, because that's just the design parameters. By the way, if you're lazy, and I'm increasingly lazy these days, I used to do this all in Excel and sit there and count that. You can now give your favorite LLM, like ChatGPT or Gemini, a prompt, and it'll dutifully calculate this for you. I just put the prompt here in the slide. All you need is the floor plates and the total CFM, and it will give you a narrative that is instructive and do your calculations for you. And look, this might not be the end all and be all, but if you are meeting set point and conditions are mild and you don't have problem zones and the phone isn't ringing with complaints already, then it helps you sort of ask the question of yourself and your team, because there are many teams on here, about what is the point of moving all that air. And Mark, and when we talked about this beforehand, of course, this is a balance. And I would never recommend that everyone go immediately to the minimum ventilation per 62.1. But I think when you see a 5 to 10 times over ventilation rate, which is what we see, it means that you got a latitude to do maybe a 10% reduction in static pressure.
Yeah, it depends on the control system and how sophisticated it is. Some sites they might have a specific minimum outside air damper that operates independently of the main outside air damper. Some sites, a calculation was done that, if the dampers are open this much, it means a certain amount of CFM. If they're open this much, it means a different amount. So really, a lot goes into try to understanding, the correlation between airflow and how much of it is actually fresh air. Here in the Bay Area, obviously we have a relatively mild weather as far as utilizing an economizer mode where we can use way more outside air than even the designers have designed for or to meet the ASHRAE requirements. One thing I want to say too is, a room, an office may have been designed for 4 people, and it has a higher outdoor air rating, minimum flow. Whereas you're finding that the office is really only occupied by one person. Now, you've decreased the requirement by 15 CFM. So a lot of it is kind of being in tune with your building and what's going on. And I can't overemphasize how important it is to keep in communication with your property manager about any kind of changes you might want to make, or your tenant facilities contacts about any changes you might want to make. I've found that everybody wants to save energy. Everybody say, "Oh, do you want to save energy?" "Oh, yeah, sure, sure. I'm in. I'm in. I'm in." So it's really kind of in a positive way, reinforcing that you're going to try something that is to save energy, and maybe it doesn't work. And then you say, okay, that didn't quite work the way we wanted. We're going to abandon that. Or you can find that it does work, share that with your tenants and your property manager. And by default, you're going to be lowering operating costs. So everybody loves lowering operating costs. So I think I'm kind of going off a little off target here, but yeah, it can be helpful it can be more helpful making changes when you have buy-in from the property manager and the facilities contacts.
Yeah, 100%. Um, I mentioned in the post, and I want to talk about sort of two ways to do this. Especially it's budget season. Maybe you've already put these types of requests in your budget. Maybe you're not going to get the full DDC retrofit that you've been dreaming of for 10 years. But look, Mark's building is instructive. There is a way to do this entirely through the control system. You need full DDC or near full DDC. And today's programming is largely based on Guideline 36, which is a new set of responsive sequences that are standard sequences. They're also built into the programming of every major BMS brand. So they're kind of canned libraries, if you will. And those G36 sequences take a very different approach. So instead of, say, resetting static pressure on something as simple as outside air, you instead look at the interior zonal demand from each VAV. Those VAVs issue requests, and the systems above the VAVs attempt to satisfy those requests according to voting algorithms and other elements at the lowest cost. In essence, a trim and respond type capability where you're always trying to find the lowest cost ability to satisfy each zone's needs. This can be done entirely through programming as a retrofit option. We've done it lots of times with customers, also calculated savings even when we weren't involved. And most of the time, this is a pretty slam dunk project. So you're looking at 2 to 3 year payback. I will say that you got to tune it. If you're going to let the computer do this,
You looked at it
and
today
Mark,
already.
yeah, you talked about this as well, but just because you've written all the sequences doesn't mean that it's going to work completely out of the box. You've got to take these request algorithms and make sure that you've weighted them correctly and make sure that you're actually getting the result from the program. But once you have the program, it's largely in place. You don't need to sit there and babysit it. Mark, I don't know if you wanted to comment on how long it took to get 601 sort of stable and in a good place with this sophisticated programming.
Yeah, so Tom, I can tell you right now, it ain't going to work right out of the box. It's not going to happen. It's not going to happen. I guarantee you.
Yeah.
But the tools that you have available to, such as Tom mentioned, is basically the programming logic is all established. Most of your what I call trigger values, most of your trigger values would be operator adjust or hopefully are operator adjustable, and it doesn't take some major programming change to change these trigger set points. What's really important, what's really helpful with DDC that you don't get from pneumatics is you have trending. And you can trend all different kinds of points and really see is your fine tuning going in the right direction. Without the trending in maybe a pneumatic building, it's much more difficult, but not necessarily impossible. You wouldn't necessarily get the satisfaction of logging in to your BMS the next day to understand if your control tweaking went in the right direction or the wrong direction. But you can somehow kind of look at your energy bills and such, maybe some meter readings that you take in-house, and try to understand in more of a big picture if your changes are moving you in the right direction. I'm very fortunate in my career that I've been exposed to Guideline 36 since the mid 90s before it was even called Guideline 36. And what Guideline 36 is to me, it's really a zone driven system. Most pneumatic, so basically the zones send out request flags to air handlers to start, to chillers to start or stop, boilers to start or stop. And nothing has a schedule except for the zones. Whereas in a pneumatic building, you don't necessarily have those same resources, and things are a much more of a top-down approach. You start your chillers at a certain time, you start your boilers at a certain time, you start your air handlers at a certain time, and then the zones just kind of ride and hopefully fall in place. So with this guideline 36, you get a significantly more responsive HVAC controls that are responding to the load as instead of controls that are operating at higher speeds or lower temperatures or higher temperatures than they really need to operate. So if you do have full DDC and you can go to the place bottom up zone driven controls, it's a wonderful place to be. If you're already there, as you probably already know, it is going to take time and effort in order to fine tune the trigger set points to meet the need of your exact site.
Yeah.
Maybe your site has a high solar load, but a different person has a low solar load. So those kind of things aren't necessarily taken into consideration when they develop the BMS logic for this G36 programming.
Yeah.
And then because I'm so passionate about all this, and sometimes I tend to ramble, I'm just going to keep track of my time here, and I can get into
Well,
some.
I'll interrupt you and say not everybody has a brand new full DDC building.
Right.
And of course, there's a simple path here, which is very different. Now, I do think you need some DDC zones. You
Yeah,
want
I would.
to be able to be in a building where you can see certain things digitally, and make sure that the changes that you're making don't violate our number one job, which is tenant comfort. You want to have comfort with the ability to make one change. And my recommendation on the change to focus on is static pressure. It's nice, it's simple, it's easy, and it's of course the beneficiary of fan laws. So even if you can take a 1.4 to a 1.3, you're saving a tremendous amount of energy because of the cubic relationship between those two numbers. Um, you can do some rough calculations as we've shown here to show you what the minimum ventilation is and make sure that you have plenty of safe margin And then you can use the standby Yelp method of building tuning, which is make very small change, document it, wait, preferably for about a week, see if there are any complaints, continue experimenting. And that's the great guideline that tells you that you're headed in the right direction and gives you feedback on the one thing that we really care about, which is tenant comfort. Um, our experience here is that operators of buildings, particularly the talented engineers we have in the Bay Area, have fantastic intuition. They know what tough days are for the building. They know what total cruise days are for the building. They know they've got a really good intuitive sense for the occupancy in the building and the problematic zones. And if they're empowered to make experiments here, they typically can save quite a bit of money by making these kind of changes, especially on the static pressure side. So there is a very sophisticated project view of here, which your controls contractor would love to give you a proposal on. There's also a get the best out of what you currently have and use your skills and intuition to curtail what your view is of excessive ventilation relative to occupancy. Um, I Why does this matter? Well, I don't know if anybody else has noticed, but their energy paybacks are getting better and better. I mean, we're now up to high 30s on average blended rate in PG&E. It's kind of ridiculous. And every time those rates go up, and property managers can comment on this. It's not like the tenants are excited that cams are going up and are like, oh yeah, whatever. Our job as an industry is to try and keep those expenses low so that we can get more people in the buildings and insulate them from causes like this. So the 2 to 3 year paybacks from these types of solutions are just getting in better and better. And of course, if you do it on your own, there is no payback. It's just pure gravy for the property, and hopefully you get recognized for those savings. Um, I wanted to sort of take one other approach of this, which is if you're not ready for playing with duct static, startup and shutdown are similar concepts of the on the same view. Because if you do view that the day is mild, and the occupancy is low, you probably don't need to start as early or certainly run as late as needed. And Mark, you mentioned this. And I don't know if people on the phone are familiar with heat maps, but these are nice little graphical ways of showing the building. So each row is a day, and then the colors correspond to the demand reading. And so we can see this building, pretty regularly starts at 5 in the morning and runs till 10. And that's 5 days a week, and they also run Saturdays. Is that really necessary in the building? Or could they get to a schedule like this where, yeah, fine, lease hours that are 8, and occasionally there's a little bit of startup, but basically the fans are on at 7, and boy, they go off pretty hard at 7 as well. And there's a little tail, but not much after that. So that's another way to try and the sort of different sides of the coin in terms of managing the resets. I thought both Mark and I could sort of like try and wrap this up and then get a discussion going with folks. But just to sum up, I think if you take one thing away from this, it's that your building, especially if you inherited a building, is likely programmed for pre-COVID occupancy. And let me see, 5 years later, is it really coming back? And if we're not starting to make changes now, like when are we going to make them? After another 5 years? Hopefully you've learned today that resets are and zonal-based demand programming is a way to match energy services to energy demand. And I think everybody can use a refresher on this and an examination of the resets that they have in their building and how deep they go. Our experience digging through data and looking at plans and doing calculations is that for most hours, most buildings are overventilating. And that means that small little operator changes here can really give you strong energy savings, um, largely on the fan side and largely because of fan laws. Again, at 20% fan speed reduction, 50% power drop. That's kind of the leverage in the game. We continue to find engineering intuition and experience are the absolute keys here, both in the sophisticated and in simple approaches. And hopefully, I've encouraged at least one of you to run an experiment and pick a low risk time. Pick like Fridays after lunch. You drop your static by a tenth of an inch and see what happens. Do you still meet zone temperatures? Did the phone ring? Are there little things like that that might give you a sense of how you might be able to save additional money? And I'm happy to report that Toby is already on it. Mark, what reflections do you have here? And then let's take some comments and questions and thoughts from the audience. I'd love to hear people's experience and questions on this topic. Oh, you're on mute, Mark.
We already sucked Toby in, so this was well worth the price of admission.
Yeah.
If we could change another person to save a little bit more, that's even better. Kind of in closing, my words of advice are to be willing to take small, calculated risks and experiment. As I've mentioned before, loop in your property manager as well as your tenant contacts. You'll find you'll get much more support from them if they're not surprised and they understand what you're trying to achieve. Always remember the BMS golden rule, which I forget from time to time. Does anyone know the BMS golden rule? Uh, okay, the BMS golden rule is to change one parameter at a time and only change one parameter at a time. Even though you want to change more parameters simultaneously and you think you're on the right path, if it does go sideways, you don't really know what the change was that made it go sideways. Or if it really goes super well, you don't necessarily know the change that made it go super well, that you can expand on that. So it's very, very difficult, but always remember the BMS golden rule and only change one parameter at a time. Document those changes. In my BMS system, ALC, there's actually notes boxes on every single graphic page. Document them there, document them wherever is best for you, but document those changes so you could kind of, well, last year we seemed to do better in June. Oh, well, in June it was this, this, and that. And it's really difficult to understand the effectiveness of your changes and such if you're not sure, you don't recall what you changed. And then lastly, to succeed with the tools that you have. Once again, I'm very fortunate. I've got full DDC, zone driven. Not everybody has that same fortune, but as an operator for coming up on 40 years, I can tell you that you have ideas that you would like to try, but you're not sure. Go ahead and with those tools you have, go ahead and try out those ideas. And open now for, I guess, question and answer.
Toby, kick us off. What did you change? And
Oh
share
yeah,
your
okay. Well,
share your real-time experiment with us.
thanks, Mark and Tom. This is a great call. Yeah, so well, the weather changed here in the last week, if anybody noticed. We finally got a winter pattern in, and it's now, getting down into the 40s at night. So yeah, I was looking at my air handlers. We have two, north and south. And I saw that our south was we have a duct static reset schedule, and the south was set to like 2.25 inches max, 1.25 inch min, which is kind of high, right? And
Right.
that would be maybe ideal if it was like, in the 80s, which maybe a few weeks ago it was here. But that's when you start to think, well, do we need that, right? Because it changed. So yeah, I just decreased both set points by 1/4 of an inch, so we're at minimum one and a minimum quarter, and instantly my fan started ramping down, and I'm thinking, well, I'm already saving money. So
Yeah.
I'm also fortunate to have those schedules in place, but you still need to be watching them to make sure they're operating properly, and then also fine tuning them as the year goes along, particularly in fall and spring when the weather changes. You want to be tuned in.
Thanks, Toby, for the share.
Yeah. Great.
Yeah, and Tom, I just want to say I follow your LinkedIn posts, and that one resonated with me. So I really thought it was a great thing to elaborate more for our engineering colleagues. I'm glad Mark was willing to share his vast knowledge in the arena of HVAC operations to expand on it.
Well, did you get your Wall Street Journal subscription out of it?
My dad has a Wall Street Journal subscription, and I grab his newspapers when he's done reading them. But no, actually, I think I'd like to get the online one. There's a lot of, I mean, the more you know, the better you are, and that's across the board in any kind of, engineers are jacks of all trades.
Yeah.
So it could be electrical, HVAC, plumbing. The more you know, the better you are, the bigger asset you are to your company and building, and also just to bring more knowledge to your team. So,
Knowledge is power.
amen.
Excellent. What other questions do we have from the audience, or shared experiences, or
Bill
thoughts?
Smart had a lot of stuff. What do you got,
Yes,
Bill?
he's been chatting.
Yeah, I've been a little chatty. Like throughout the years, I've had different buildings, both pneumatic and digital, and some of them a combination of everything. Um, I think the biggest thing is state of the basics. Keep your air handlers running smoothly. Check, have a once a year air leak survey done, whether you do it in house or otherwise. I mean, a 1/4 inch of air is 20 30 horsepower running full time 24/7. Shut down floors that you don't need. Physically go shut the dampers if you have to. I shut 3 floors down. That's 3 out of 15 floors. That's a big, huge savings right there. I was able to lower my static pressure and save the building a lot of money. So stay on it. It's every day you got to make adjustments. Every day you're changing something somewhere. New building, new room, new tenant space. The printers being put right where the thermostats are, and they don't want to move the printer, so
Classic.
you wind up moving the thermostat. Then they're wondering why they got an $800 bill. So I told them, I says, it's not free. If you put your thermostat there, we could have built that building differently. We could have had that thermostat somewhere else if you didn't change your floor plan. They decided to put a big printer there. They're wondering why they're freezing. Well, here you go. All your heating
That
valves are shut
happens.
because it's 90 degrees.
It's a classic
You know,
example. Yeah.
to-
Sure.
yeah,
And
Toby brought up a good.
shutting off the floors is great. Obviously, you want to make sure that that's compatible with leasing.
Yeah.
And then if you have VAVs, you can do it at the VAV level. You can also tie in fire smoke damper as well.
Yeah.
That is permissible across the Bay Area. It's quite common, and it's a good way to air isolate if you don't have isolation dampers.
Yeah, especially in pneumatic buildings, usually the fire life safety is tied into those floors, and the uh, the fire marshal, they agreed. I'd rather have the floors ventilation shut off than on.
Yep.
Like Toby says, we need to know when those tours happen. Have property management set up a schedule. Get on a calendar invite that, hey, there's a tour at 1 o'clock tomorrow. we know to open up that floor at 10 just to get the air moving, get the, the staleness off that floor. If we don't know, I'm sorry, it didn't smell good up there because it's been stagnant for 6 weeks, lease it out sooner.
I think it's a great way that property managers can help is if there's a better trust and coordination on that, then I think the engineers are more likely to save money on the unoccupied floors.
How many times you get called and, the conference room is burning up in here, and you go up there and there's 90 people in a 20-room conference room, and you're wondering why. It's like, well, we got you. What
Every
spots
one of
are
us
the?
is a 100-watt bulb.
Yeah, the more you know.
You don't know that.
Yeah.
That's roughly what a human produces in terms of the excess heat. So, incandescent bulb, not LED.
Yeah.
Yeah, I brought,
Sorry, Gary. Go ahead, Bill.
Yeah, I got with the tenant and they gave me their schedule for their conference room. So on those days, I lowered my air handler temperature, to help out with that space.
Yeah.
So if we know, we can help. If we don't know, then it's usually too late, to go up there and try to cool a room down after you had 90 people in there. It's not going to happen, But I think that's the more we know, the more we can help out. And I think those relationships are key with property management and also the tenants.
Yeah, 100%. Thanks for your comments, Bill.
You're welcome.
Tom and Mark, thank you so much for this. This was a great webinar. I think there was a lot of information shared. It was very valuable on saving energies, relation to fan speeds, relation to power. It was just great insight. It was deep. And I think the point got across. So once again, thank you both for putting the time together. I know you worked together last week and a little bit this morning to make this work. And I think it flowed just great. Everybody, thank you so much for joining. We're looking forward to the next one. And I hope everyone has a great holiday season. That's for sure. I'll see you at the BOMA parties coming up and all the other good stuff that's going to be happening.
Rick, thanks. Jesse,
All right,
thanks for
thank you.
helping us all together.
You guys.
Great job.
Good job.
Thank you.
Good job.
you.